So in your homework, you also have to use a tree diagram to solve some word problems. I've got another video that goes with question 25 in your homework, so feel free to watch that video as well that goes with your homework, specifically working out an example that was tricky. So using a diagram, using a tree diagram, let's see if we can kind of work this problem out here. So probability experiment consists of tossing a coin and spinning the spinner shown at the left. The spinner is equally likely to land on each number. Use the tree diagram to find the probability of each event. Notice this sounds like classical probability, equally likely kind of stuff there. So the first thing is event A is tossing a tail and spinning an odd number. So let's say we've already got our tree diagram. So we have heads and tails, and we have 8 numbers on a spinner that are equally likely to happen. So these are our sample space. So notice that that's our tree diagram that they've actually already made. So tossing a tail and spinning an odd number, what we'll pick up on is we have to figure out, our sample space is going to be all of the outcomes. So we have 8 here and 8 there. So it looks like there's 16 outcomes altogether. So our sample space is going to be this 16. Now, what we need to do is our event is tossing a tail and spinning an odd number. So we need to find how many outcomes are actually in that event. So I have to have a tail, but also have to have an odd number. So we're seeing tail 1, tail 3, tail 5, tail 7. So 1, 3, 5, 7. That looks like 4 of those outcomes. So for question 1, our probability should be 4 possible outcomes there out of 16, which would be 1/4, or in other words, that'd be 0.25 as my probability. So event B, tossing a head or spinning a number greater than 3. So that one looks a little bit different. Tossing a head or spinning a number greater than 3. So we have 2 different things going on here. So we have to figure out our sample space. So again, we have 16 is our big sample space. Tossing a head, how many of those do we have? So we have 8 outcomes with heads. And then spinning a number greater than 3. So I can't count the ones that have the heads already because that's double counting. So greater than 3 means like the 4, 5, and the 6. So we can't count these because we've already kind of counted them in my set. So, but we can count the greater than 3. So we would have what, 4, 5, 6, 7, 8. Those have to be excluded there. But I could count them over here on this greater than 3. So 1, 2, 3, 4, 5. So I have 5 there that would still have not been counted in my set. So my sample space would actually be 5 more because these had already been counted. So we should have actually 13 in the total sample space out of the 16. So you should have a 13 out of a 16, since that's going to be our total sample space, our subset. So 13 out of 16 looks like what we have here. So let's see if I can find my calculator again. Can you get smaller? Okay. Let's see, where did my thing go here? Okay. So if we do 13 divided by 16, we end up within 0.8125. So in other words, 0.813 would be this sample space. So that's how we can kind of work that problem out is if you're using a tree diagram is you actually can identify your sample spaces with because all the numbers are present there. So let's see if that helps us any.